That, I'm sorry, can you please reset that link to that video? Sorry,
Which one?
on the this thing. As I left, I didn't copy it fully.
Okay,
Sorry.
no problem. Okay, there is the video is, look at it, in 12 minutes to be ready, as you can see. So
Thank you.
thank you so much. Now let's talk if else. Let's talk if else. Now, if I go into if else, you want to pay attention to the fact that the compilation of a C program goes through four processes, four stages, right? Anyone wants to help us with what those four stages are? Anyone?
Looks like it's just you and I.
Go ahead.
What page is interpretation? No. I don't clear my head.
You do something like this.
Something like this.
Pray.
Three.
Okay. If I add pro,
Add pro.
just remember.
Preprocessing.
Great.
Great.
So there's a preprocessing stage followed by
Followed by
uh, interpretation. Interpretation sounds like something that happens. Sounds like you're talking about interpretation. Sounds something that happens in one of the stages. All right. So you want to know which one follows? Compilation. Ah, interesting. Okay. Next. Did you know about this? Assembly and then linking. Great. Thank you very much.
Thank you very much.
May please be muted. All right. Now these four stages of compilations are actually what our files go through. What the C file goes through at that point of compilation. There are things that from one state to another, different things happen there. Now, I'm not going to explain that because there are several videos explaining this. In fact, you have a lot of materials on the internet explaining this very well, what happens in all stages. But the main thing you want to go home with, the main thing you want to learn from all of these, or to learn about this, is how to manipulate a file to not go through the four stages. Right? You can make a file stop at a certain stage. You can make a file preprocess and not compile, or compile and not assemble, or assemble and not get linked. All right, let me go to our previous work. What's this? The part to C. No. Appear the part to C. All right. Okay, this work we did here, for it to have produced an executable, it means it went through these four stages. Instead here, but we could make it go through some stage and not get to this point. And each stage has something about the output, its output. For example, this is the point where we have the C file, the source code, and it has a .c file extension. But if I pass this thing through the preprocessor stage, as a result, some output that I expect. An output that I expect. Okay, what I mean is this. Let me come here and make a new directory. I'll call it stages of compilation. Alright, I'm going to cd into stages of compilation. Watch this. I can have a file. Let me go and copy what I have in the other file. Intro. Let me copy that main.c file. I had a main.c now. I thought we had a main.c there. This is strange. Okay, my command is not. Alright, copy. Okay, it's great. Copy it into this point. So now we have a main.c, and if you're in that format class, you know the content already, right? Let me zoom in a bit. Alright, this was the content, and let's make it a bit. Okay, we're going to vim today. So vim main.c. Let's reduce the content so that you know what you're doing. I'm going to cut off this line of code, and then I'm going to take off all of this. Make this a bit simpler. Let's do a simple hello world program. Oh, sorry, may have to leave and join again. My screen is shared right now. I think it's from your network. Thank you. Alright. Did you say you'd be expecting it? Like I'm saying, my screen is shared, but since you're not seeing it, I'm suspecting your network. If you could just leave the call and join again, it might help.
Okay.
Alright, thank you. Thank you. Now, we've got here this program. Let me clear the screen. I'll show you again what we've got inside main.c. It's a simple hello world program, right? So when I do gcc main.c, this guy produced here called a.out has passed through these four processes: preprocessing, compilation, assembly, and linking. But I could make it not go through all of these processes. How? Well, this is how to find out how. Do man. Man stands for manual. Right? Man stands for manual. Okay. So man is the command, and then GCC. That means we want to know about GCC. We want to know what is written in the modern Linux manual about GCC. So I press enter. Here we are. First thing you want to pay attention to is the description, right? It says when you invoke GCC, it normally does preprocessing. You see that? Preprocessing. It does compilation. It does assembly, and then it does linking. The overall operations allow you to stop this process at an intermediate stage. That means you can stop it and make it not complete. For example, D-C or -C, like I like to call it. This option says not to run the linker. That means run the preprocessor, run the compilation, run the assembly, but don't link it. What do we mean by option C? It means when you type GCC and put -C, that is what will happen. It will not get linked. Let's exit this. To exit this, I'll press Q, letter Q. Now I've exited. So it's saying that as I did GCC main.c to produce this, if I had done GCC and did -C and then pass the file main.c, that it will go through the three stages and not compile. And then this is the result of going through the preprocessing stage, the compilation stage, and the assembly stage without linking. It will produce the same file, but with another extension .o. This is what we refer to as an object file. Right? It's not linked. It stopped at the assembly stage. It generated assembly codes. Well, I'm going to do the practical aspect, not to tell you exactly what happened in every stage. You want to read some documents or see some video about that. Uh, but you need to understand that, okay, let's try redirecting the output, right? And say, I don't want it to be main.o. I want the output to be, so if you don't want that, you come here and put hyphen o and put the name that you want it to bear. Let's say new, right? New, and then compile. If I list what I have here now, you see I have new there. In other words, this is the what would have come out by default, but I want this to come out. Here, this is what comes out by default. Let's take it again from the top. I'm going to clear the screen. This is what I have here. I'm going to delete a.out. I'm going to delete main.o, and I'm going to delete new. All right. Here we have main.c. If I do gcc main.c, it produces by default a file called a.out. But if I don't want to produce that file, let me remove it now. A.out. We have only main.c here. If I do gcc main.c, right, and do hyphen o. By the way, if I do hyphen o immediately after gcc, it still works, okay? If I do it after the file, it still works. What is important is that that new file that you're creating, that you want the output of your work to be redirected to, you have to state the name immediately after the dash o. You have to state the name immediately after the dash o. So I want the name to be compiled. So here we see the name is compiled. So if I had done this like this, where I remove this from here, put the hyphen o immediately after gcc, and give it a name. Let's say new file, and press enter. It still works. So it doesn't really matter whether you choose to put it this way or choose to put it after gcc command. What matters is that after putting this dash o, you don't follow it with the file you want to compile. You follow it with the name, the output, the desired output, where you want to redirect your output to. Very important, very, very important. Okay, now the same thing happens for the what's it called now, the other stage. Okay, it has a default file that it produces, but you can choose the kind of file you want to have from it. Okay, let me do this way. Let me call this one, I'm going to make a new directory here. I'm going to call it linking. Let's say after linking. Okay, let's say linking. Yeah, linking. The position linking, right? I'm going to move everything that is here into linking. By the way, let me generate the default file as well. Move to linking, right? And so I'm going to move everything that is here into the directory called linking. Yeah, and I did that because I want to separate my logic, right, for each of them. Now let's make another directory called assembly, right? So I'll make the directory. Or maybe I should name it after assembly. After assembly. All right. I think I want to rename this one to after linking. So after linking. All right. I have moved into this directory named after linking. What happens when you compile a file, C file fully? Now I'm going to quickly move into this other file that says after assembly, and you've read that from the manual. Let's take that again. Man gcc. We've seen that, for example, this option says not to run the linker. That means the option says, hey, preprocess it, compile it, assemble it, but don't run the linker stage. So that is why I'm putting it inside a directory named after assembly, because after assembly it didn't get linked. Okay, so to do that, if I just, I'm going to copy the file, main dot, this file you're using to work, right? Hold on, please. Okay, I'll copy to this place. Here we have it. Now let's run this command that runs this file through the three stages and does not include the fourth one. So by default, it is main.o that is produced, just like a.out is produced by default in after the linking stage, right? After linking. So, but even as this is produced, I could decide where the output to be redirected to, such that instead of having that one, I will have what I want as the output. I'll have it inside the file I want it. So to do that, I'll do -o. Remember that this -o could be either this way or this way. What is important is that what follows it is a name. The desired file you want to attribute it to. It could be only one letter. It could be only A. It could be only B. Whatever it is. Whatever it is. So I could, let me just do ABC. Now it's the process was successful, but it redirected output. Redirected, that means it channeled the output and changed the direction of the output and sent it to this file. It created a new file with the name I gave it and sent the output there. That is this stage for you. I'm going to move out of this directory and create another directory named after compilation. Let's see what happens after compilation. Okay, so after compilation, I'm going to as well move into it and copy the file we are working with. So let me copy it from here and bring it here. Let me clear my screen. Here it is. We have it inside here now. So we want to see what happens, how we can stop this from here at this stage, so that it does not go to assembly stage. To find out how we do that, let's check the manual. So man GCC Okay, here we go. As we this example, let's go further. Now you want to scroll down because you don't want to read everything, right? Reading a bit of the description is fine. You're not expected to understand everything that's written here, especially as a beginner, right? So start looking for what you're looking for. We want to make it stop at the compilation stage. So keep moving until we get what we want. This is not it. This is not it. This is not. This is talking about static analyzer options. Keep going until we see what makes sense to us, what looks like what you're looking for. And we'll stop. This one looks like it, but it's not the preprocessor options. That's exactly it. Assembler options. That's exactly it. So we are going down, keep going down, and down, and down, and down. Okay, let me go speed and keep going down. You can take your time. I'm going this speedily because I know that it's far down, but you don't know. Don't go. Take it. Move more gently than I'm moving now. Okay. You can see now. It tells you that hello, compile or assemble the source files. Right? It tells you that you pass this option. It said the linking stage simply is not done. So if you pass option C, the linking stage is not done. You've seen it. So we want to see the stage, the one that we are going to pass, that the assembly stage will be not done. Like the one that will stop here and not go to the assembly stage. Let's be watching all the options and check. They say if you pass -S, this S is uppercase S, right? They say if you stop after the stage of compilation proper, you see. So do not assemble. Do not assemble. He said the output is the form of an assembler code file for each non-assembler input file specified. Forget about that plenty of grammar. Let's go and do it. Now I'll put a receipt here by pressing Q. I will come back later. That means I need to pass. If I do GCC, remember we have the file inside here already. So if I do GCC and say hyphen uppercase S and pass this file to it, main.c and press enter. Let's see what happens. It gives us a file with the same name but with another extension of .s. .s. So we've produced the assembler code, the code that will be assembled, but was not assembled. Meanwhile, in the other place, we produce object files with .o. These are things you should understand. Now, apart from the fact that its default is now, after linking, the default is a.out. After assembling and you refuse to link, if you stop it and don't let it link, the default will be the name of the file with a .o extension. And it was main.o because our file was named main.c. If our file was something.c, it should have been something.o. Here too, it takes the name of the file that you pass to it and then remove the .c and add .s. This is the default, but we can actually produce our own by redirecting the output and avoid getting the default by running this command again and adding -o and adding the name we want. Let's say my file. Great. So now you see this is the default. This is the one we are redirecting the output to. I redirected the output to this place. Okay. Next, how do we now stop it at the preprocessor stage? We don't want it to get. We have seen the one that gets to this point. This is the point where we get a.out. This is the point where we get .o. This is the point where we get .s. We want to get it, make it to stop at this point. This is not even compiled at all. How do we do that? Let's go back to our manual. So man gcc so let's scroll down back to where we saw that stuff before. Alright, you're almost there. Okay. Here is -c, we've used this one. Here is uppercase S, we've used this one. Here is -o. Says they place the primary output in file. You've seen what -o does, right? Place the primary output in file. That means any file you name, it places the primary output there. Then -e says stop after preprocessing stage. That means do not run the compiler proper. Now this one has a funny kind of output. Plenty things. I'm going to press Q. Remember, we have seen that the option to pass to GCC to stop it there is -e, right? So I'm going to press Q. Back to this place, and let's say GCC. Okay, I need to make another direction, right? Let me leave here. So after preprocessing. Great. Whoa, all right. After preprocessing, what happens? Let's go and copy from this place the file you're working with. And here we'll have it here now. I'm going to clear the screen. This won't have here again. So if I do GCC -e and pass the file to it, this is what happens. You see plenty stuff printed here. Plenty stuff. Look at them from this. See how lengthy it is. How lengthy it is. How so lengthy it is. So lengthy. Plenty of things that I'm wondering what is happening. Like I said, go read about this stuff. Read about it and know how it works. Actually works. And see, still going. See around the command. But know that just the same way we do echo. Let me clear this screen, please. The same way we do echo. What does echo do? Echo simply prints whatever you give it out. So echo Topman is here, and you press enter. You print the Topman is here. So when you learn shape directions, you learn how to do something like this, where you add a greater than sign here and put a file. Let's say A. It will not echo it again. It will not go and save it inside that file. It means echo normally should print this thing out, but because you're redirecting the output, right? The output will not go and save inside a file you set access to save in. Now, if that file does not exist, it will create the file and put the output inside there, and that is what it has done. Let's see. Let's list what we have here. You can see that we have A here. So if I cut A, if I say let's see what is inside A, you see showing that Topman is here, is inside A. Quite interesting, isn't it? So this redirection on shell using greater than sign is the same thing you do when you pass hyphen O to GCC. You're redirecting the output. In other words, if I do GCC and say hyphen uppercase E as in main.c, this guy does not, GCC does not save its work anywhere. Like when you run a file through the preprocessing stage, it does not save the work anywhere. It just outputs it, like this. But if you want to have it saved somewhere, then you can put the same thing again, hyphen O, and say save it in a file named ABC. So go. Now it did not print those plenty of rubbish again. Why? It has saved those plenty of rubbish inside the file named ABC. Right? So I'm going to delete. Okay, let's not check what is inside the file ABC. You're going to see that it is that same plenty of rubbish that I printed before. Pardon me for the one I'm using. Alright, so look at it. What it would have printed that way on the terminal, we have redirected it and saved it inside a file. The next thing you want to know is that you can have a bash script do this for you. I'm not going to do that part. You want to see the other video where I run some bash scripts and made it work. I also have a short video on my channel as well that explains bash scripts. You can find it on the playlist that has to do with something software engineering basics, something like that. That's it. Okay, for now let's move to this other what now? Objectives that we have to cover very quickly. I want to learn these basic concepts. But if you have any question about these ones I just talked about, please go ahead and unmute and ask. If you're in the live audience, I can see quite a number of you who join live. And if you're watching on YouTube and you have a question, please post it as a comment on this video and I will attend to you. Okay, so what are the arithmetic operators and how to use them? These are the objectives that they gave us to cover, right? What are arithmetic operators? So I need someone to talk at this point. What are arithmetic operators? If no one talks, I will skip it. What are arithmetic operators? Just submit and talk.
Those should be the regular operators, subtract, divide, multiply.
Thank you so much. Modulos, interesting. Okay. All right. Thank you so much for your response. Well, we are talking about these basic ones. Modulos is arithmetic here because it performs some arithmetics, right? Giving us a reminder. I never thought about it, but I think it's arithmetic. Yeah, it is. And then so we have other kind of operators in C, right? We have several of them. Let me try to list them somewhere here. My body is getting rough. So we have arithmetic operators, which one of us, that was Randy, right? Randy just gave us some examples. Operators. Yeah. I think there are more. You just occurred to me that there are more of them. This 1, 2, 3, 4, just the basic ones. There are more of them. So long as it's arithmetic, it does some calculations. So we have the logical operators. We have relational operators. Several of them. I think I should mention the boolean operators as well. Right, and then I think This is about it. It's just not forgetting. Yeah, there's something called bitwise operator, but we may not talk about it at this point. Bitwise operators. Um, there might be more. Oh, thank you so much. Assignment operators. Thank you so much. All right, let's find out how these kinds work. Okay, by now you can write a C program. So I will be confusing you if I go to my terminal now and start coding. Arithmetic operators, like Randy has said, are those ones used in performing um, arithmetics, using calculations. He said normal ones we use in secondary school. I want to separate them with commas, right? Asterisk is actually what we use to represent multiplication in programming. Okay, that's why I put it there. It's better than using x. So if I do this, it's this is we're saying raised to power. No, yeah, raised to power. So if I do 2 asterisk 2, I mean 2 star star 2. I'm like saying 2 raised to power 2. That's just by the way. That's just by the way. We have them in C, right? We have this in C. They are used. They can be used if you want them, and used to achieve certain results. Let me see whether I can have these on a different board so that it will be too crowded. Alright, so I'm going to cut it. Come here, paste it. Oh. Alright. Okay. What am I doing? Okay. Let me copy this as well. Just a proper illustration. Okay, I'm gonna paste this here as examples of arithmetic operators. And let me just do this. So logical operators, let me do this as well and give examples. To avoid confusion, let me just move the comma. No, I think it's fine. I think they are fine. Now, logical operators are, like the name implies, they are used for logic. Is it like this? Is it something you want to make logical comparison between certain factors? Use these logical operators. Okay, and we have this one, the and we'll have 2 pipes put together called or. Who knows another one? Or who knows another one? Tell us, Thomas. 2 equal signs. Okay, that's actually not a logical operator, is it? It is not. Actually, if you put equal to in C, this is not really equal to in C. So that 2 equal sign you're talking about is really what we call equal to. It's the equality sign, you see. Okay, so it's a relational operators relating 2 variables, relating 2 values, right? So that's why you also have things like this, things like these as well. So this second one will be. Am I putting it right? I think it's like this. Someone correct me if I'm wrong. Which one is correct now? Somebody help. Greater than or sounds correct, right? Thank you. Thank you. So It's trying to compare it, so it's trying to relate, right? And then we have, of course, we have less than, we have greater than. They're all they're the relational operators talking about here. And then for Boolean operators, we have two values, right? Boolean operator is just two values. Two values. Who wants to help me with these values? Thank you. True, comma, and false. And in C programming, um, you may not see something written true or written false. You may not see true printed out or false printed out. But there's a way we know them, which is by who has not talked in this program, in this meet. There's a way we know them in C. Mr. Joseph, you want to help us? Um, Hamdi Ibrahim, confidence. Oh, Carpenter John is in this call. Alright, so in C programming, we have true as one. Yeah, true represented as one, and false represented as zero when it's time for using Boolean values. Okay. Now, assignment operator. Let's say operators. Are there more than one of them? Alright, assignment operator now is now the equal to. So you put up equal to, you're not saying equal to, you're saying assign. Assign. I mean give to this thing, this value that follows. Give to whatever is on the left side, the value that is on the right side. That's what it means. That's what it means, okay? So bitwise operators, I'm not going to talk about this now. Okay? Because this is not what something you want to tell a newbie. At this point, you need to learn how to let's learn how to use this ones first. We're not using this one in this program. Maybe I should just take it off. Okay, maybe I should just take it off. Yeah. But there will be a point when you will learn that. Be a point when you learn that. So someone wants to ask a question, confidence. Decrement. I'm not sure. I remember exactly. What will I call that one now? Sorry, I don't remember. Only the. I'll just go ahead and give it my own name if I try to force it. I don't remember. Plus, plus, minus, minus. So operators in C. So does anyone know in this call the plus, plus, minus, minus? Now we study the precedence, the one that comes before, the ones that comes after. What operators are they? If you remember, I'll use and talk. Otherwise, just continue. Or if you know it, teach us. Okay, now let's make progress. So they say, what are these and how do you use them? What are these and how do you use them? Sometimes called Boolean operators. Yeah, logical operators are Boolean actually, because their result is Boolean, right? The result is Boolean because when you put is this thing like this and like this, the answer is always yes it is or no it's not, right? So what is the relation? What the relation operators are, how to use them, what values are considered true and false, true or false. We just say this now, 1 and 0. What are Boolean operators and how to use them? We've discussed that. We need to show how to use them, right? And then we'll come back to if else. So let's work and let's do something with this 1, 2, 3, 4, 5 objectives spelled out here. All right. Yes. Go ahead.
What of the exclamation sign? That
Oh, thank you so much. That should be in comparison. Operators, relational operators. So that should be here. Um, want to call it not? I think it's relational as well because you want to check if something is not equal to. like something is not equal to, and sometimes it could come as it's logical. It's logical now. Where it comes is not really coming with a port to start. It's coming to check whether it's coming to bring a, a boolean result. So I think it could be logical as well, not here. Yeah, thank you for that. Let's do some coding. Ready? So I'm going to move out of here. Uh-huh. Here we go. I'm going to create a directory. Let me call this one. I'm using operators. Or using C operators. Actually, it's using operators in C. Okay, using C operators. Okay. Here we go. I'm going to move into it. And here we go. To save time, I'm going to quickly copy what we have here in this place. Of course, I made the main dot C5 into this place, and now we'll have it here. Now let's modify the program to what we want. I'm going to use Vim and main.c. We want to start using these operators. Let's begin from arithmetic operators. How that we can add two numbers together. So if I come here and declare a variable, we've explained what the variable is, right? And how it is being declared in C. Yeah, we're not going over that again. If you don't really understand, please see the previous video where we started this. So I want to declare a variable of type integer. Let's call this one num1, and here we go. I just declare the variable, and then let's have another one int num2. This point is what we refer to as declaration of variables. This is a comment I'm about to add, so I'll do this. Say declaration. Of variables. Alright, do this. That's a single line comment there. And then next now to do is to initialize the variables. And so I'm going to take it, keep a space between them, and then I'll put another comment here. Call it initialization of variables. Alright, making progress. So what happens here is this. This is the point where I assign. It's like assigning of value to the variable, assigning initial value to the variable. That's how I defined it the last time, right? Look at it. Initialization means assigning an initial value to a variable declared. So we want to assign a value. We want to assign values to these variables that we declared up here, right? So we're going to say num1 equals. So we are calling it equals, but in C is not equals. Yeah, so what the statement is assign the integer value 4 to the variable num1. Okay, and this other line, let's assign a value to this other variable 6. Okay, please, I don't want to start repeating some things that I've said in other videos, so just try to follow the series, okay? But if you ask some questions, I will answer if you find anything confusing. Okay, now the next thing I want to do is, remember, just so you know, what we did here can be done in one line. How? Like this. We'll come and say num1. Sorry, put int once. Int num1 equals 4, comma, num2 equals 6, and then semicolon. This will work perfectly well. I just wanted to separate my logic. I just wanted to separate declaring the variables from initializing the variable. Great. And now let's try to print out. Let's try to use some arithmetic operators on these stuff, right? So go ahead and say let's perform addition. All right. I can choose to just declare the variables and say a new variable and say int um, added, or let's say sum, or I don't want to use sum because sum is very common such that your some of us our brain is programmed that yeah it has to be sum. The result is there too, but then it's not bad. Just so you know that anything can work. Um, let's say new value new value equals. Now we are saying, remember this is not really equals in C. We are saying assign to the new value what I'm about to do. You perform this arithmetic operation, add this and this, okay, together, and whatever it gives to you, put it inside new value. Right? By doing it, you're saying you're working with integer values, so you have to expect integer values. So after doing this now, I can come here and print it. Okay, I can come here and say um, this, take this off, and bring the format specifier that prints integers, percentage I, and of course I want a new line to be printed after everything. And then I come here, put comma, and put the variable, the container where I want it to go and get that stuff from. So go into the variable called new value and get its content and print it out for me. Now I'm going to save this. I don't want to. Okay, I'll just run this in the background. And then next thing I want to do is to compile the file. So let's call this GCC file 1. Sorry, there has to be a hyphen O here. Right, compile, no error. That's it. So if you run the file dot / file 1, it prints 10. Of course, remember we added 4 plus 6. Added 4 and 6. We can even make our output more beautiful by making it look like this. Say percentage I plus percentage I equals percentage I. By doing this, what we are saying is this. We are saying dash plus dash equals dash. That's what we are saying. So we have to give it 3 values here, 3 additional values. Of course, 3 additional arguments. Okay, so the first dash, which is what I'm referring to the format specifier to be, we'll go and take its value from here. We are saying go and take your value from here, num1. Right, and next one, go and take your value from num2 and print it for us. Let me save this and run it in the background. Let me compile that file again, but this time I'll call it file 2. We compare with that error. I'm going to clear the screen, show you what we have here. We have file 2, so let's run file 2. Look at it. 4 plus 6 equals 10. Now note that this place is just a string, okay? Just a string. Where the thing is happening, this one is not what is adding it. It's not what is adding it at all. What do I mean by that? What do I mean by that? I mean, if let's say, let me declare a variable now, a new variable. Let's just do this. Just experiment. Int in num3 is equal to 100, and come here and say and put num3 as the second argument. Let me save this. I'm going to compile them again, but this time I will call the output file 3. Now file 3 is here. Let's run file 3. It says 4 plus 100 equals 10. How funny. It shows you that the addition is not being done inside that string. Okay, because this 10 now is contained in the variable called new value, and as far as new value is concerned, it has instructions to add what is in num1 and num2. It doesn't know what is happening here. It's not concerned what is happening here. And as far as the percentage I that is here is concerned, it has instruction to take from the second variable, right? Second variable after the string, and the second variable is num3, so it took 100. This one has instruction to take from num1, it took 4. So I'm going to go back to that place and take off that line. So let me just undo that. I think we're good like this, right? Great. Okay, now having known that you want to perform subtraction, multiplication, what does modulo do? Modulo shows you the remainder. Okay, for example, let me just do that one. For example, if you have let me write some more of the program. Let me write some more programs here where I just say using modulo, which is this. I should have it in brackets. Okay, so I'll just go ahead and do a quick printf. Come on, right in there, and say let me hard code it right. I'll say 4, or let's say 5 over 2 equals percentage I. I want a new line, of course, and I'll close the string, comma. What I want percentage I to do is to divide 5 over, to check for the remainder when 5 is divided by 2. That's what modulo does. It checks for the remainder, and you know that if 5 is divided by 2, the 2 will have 2, but there will be remainder 1. Okay, so remember, this is just ordinary character being printed out. This is the thing that is magical. This is where arithmetic is going on, right? And this person said I will go and take its value from the result of this arithmetic. So this should give us 1, right? So let me comment this line off. Alright, and save this, and then run it on the background. So I'll compile again. I'll call this one 5, 4. I'll say modulo. Let me call it modulo. I mean, this file something is not making sense again. Before I have up to 525. That was new. What's happening here? So this is it. Let's run modulo. So modulo says 5 over 2 equals 1. Should I even say 5 modulo 2? Why did I say 5 over 2? You see now, I typed something wrong and the printer did something wrong. So let me say 5 modulo 2 is equal 1. So let's add 5 over 2. Okay, let's just stop here. Okay, you can do that one. So the background. Let's now run it. Let's now compile again. As a problem. Oh, remember in printf, if you want to use that percent sign, you have to put 2, right? Because percent is a special character in printf, so I have to have 2 here. I have it saved. Go back. So for the 2, it will print 1. Compile now. It compiled. I'm going to clear the screen. I'm going to run modulo. So it says 5 modulo 2 equals 1. That's it about arithmetic operator. Let's move to the next one. I think I want to move with speed now. I want to move with speed. So I'm going to using I think I'll be using all these ones almost at the same time. Almost at the same time. That's where the if comes in. If else comes in. So let me. What was F1 for? What does F1 do? F1 adds 2 numbers. So let's change it to add. Add 4 and 6. Let's rename file 2 as well. File 2. Let me see better formatted. Add. Let's just call it add. Add num. Okay. What does file 3 do? Okay. Experiment. Let's call it wrong output. Okay, so if you're interested in these files, I'm going to push them to GitHub, and you're going to find them on this repository named the part to see. Yeah, this way I push goes right on this section, right? So you can go there, find them. Feel free to make a copy of the repo if you want to. You can fork the repo, you can clone it for study purposes and play with the codes. All right, that's by the way. Now let's quickly check out these ones. So how does if else work? I think in using if else, we now start using these operators. How does if else work? This is how it works. You can see me clearly, right? Thank you. Alright, so let's make a new directory and call it if else. So I'm going to move into C if else. And I have something running in the foreground. So let's create a new file. I think I want to copy what I have here. Okay, so let's try to use. So let's say we want to divide 4/6, right? So let's make this code a bit cleaner by making the lines of code shorter. So I'll do this. I'll take this off, and I'll take this off. Okay. Alright, let's say we want to have this, want to divide these two numbers, right? But we want the numerator to be bigger or larger or greater in value than the denominator. Okay, so 4/6 will give us 0 actually. Yes, it will give us 0 remainder because we are working with integers, so it won't give us the remainders or decimal points, something like that. But then, let me show you what I mean. I'm going to take all of this off and say num1, no, percentage I divided by percentage I equal to percentage I. The first one should take its content from num1, the next one from num2, and the next one I can choose not to store it in a variable and put it here straight. So I'll say num1 over num2, right? So we're good. Let me save this. If there's no error, it will compile just well. So let's call the output, let's redirect the output into an executable file, mdivide. Oh, there's an error. Oh, I'm going to fix that. And let's fix that. Right? So I need to say int num1. I told you this will work on like one line, right? So let's have them all in one line. Comma here, like this. So save now. Let's compile again. No more error this time. I'm going to clear the screen, and we have divide here right now. So when we run the file, divide says 4 over 6 equals 0, and it is true because it has to be 0 point something. But since we are working with integers, it is not interested in the decimal value. It's not interested in the fraction. To get the remainder, we need to use modulo. If there's a remainder, okay, there's no remainder in this case. This is 0 point something, yeah. So it's not just in the fraction, right? But then let's just say want our program to be able to divide two numbers and take the highest one to the front, to the upside, right? So when I put an if statement here, let me take this down and start if statement, if block of code. So if this how it works, you now put the condition inside parentheses, it's inside open and closing circular brackets. Okay, so and I say if num1 is greater than num2, I want to press enter, come here, put my curly brace. Is this syntax correct now? This is strange. What am I missing? Quite unusual. Looks like I'm missing something in this syntax. Okay, let me just go ahead. If num1 is num2, is this still not set? Interesting. It's okay. So we have to put the instruction inside this place. So I want to copy this now and say if num1 is greater than num2, then do this. So let me cut this from here and paste it here, and I'll move it like this because it has to be indented to show that it's inside the if block of code. Then when I put our else statement, I just hope I'm not making a mistake with this syntax. Okay, and then we'll say else. That means if that's not the case, else. That means if num2 is bigger, do turn, how do I state that, like make the division to be the other way around. Let it be num2 divided by num1 instead of num1 divided by num2. So I'm going to add my curly brace here as the syntax demands. Okay, and this time I'm going to change the order, right? It should not do num2 over num1 is equal to num2 over num1. I hope this is not very complex, right? So let's try again now. Let's try again now. So let me save this and try to compile again. Divide divide div, let's say div with if else. Oh, there's no error, right? That's great. So we have it here. Let's run it. Div with if else. So we printed 4 over 6 equals 1. Let's go and check whether our code is really working well. By changing the value of num1 and num2. Let's now make num1 bigger. So you know that what we started, we said if num1 is bigger than num2, go ahead and state that num1 here over num2 here is equal to whatever result is. But here we say if that's not the case, if num2 is bigger, that means else. That is if this thing is false. Because this thing we evaluate, that's why we say these operators have to, at the end of the day, they produce boolean value, either true or false. Because if it is true, it will do this one. Now, if it's false, it will go and do what is written in the else block, which says that you should now take the second number to be the numerator and the first number to be the denominator and perform the division. Now, let's now make the first number bigger and see whether our code is really working. I'm going to take this off and put 10 here. Okay, let's put 12. And we'll stop having reminders. Alright, now let's go and compile that file again and run it again. It says 12 over 6 equals 2. Now let's make sure that our code is really working. Let's go and try it. Let's go and make sure that it's our code that's really doing this thing. And I'm going to make this one now smaller. I'll make it 4 and make this one 16. Because of the conditions we've put, it will go and put the bigger one at the top. Let's confirm. Compile that file again and run it again. So now it did 16 over 4, which is equal to 4. See the magic? It's working. It's working. Okay, let's take it and make it more complex. Let's go more complex. And this, so okay, by the way, I want to set my Vim because it's not really working the way I want it to. Permit me to set it. It's making me do everything on my own. Oh, I think I should just use max. Let me use max. Sorry. I'm gonna use this. It's not. It's making me press all the tab spaces manually. So Emacs. What's that file again? main.c. Oh, I've called the Windows. I don't want this one. Sorry. Great. We are good to go. I'm going to have another terminal here. I'm going to be doing the compilations and the tests. Okay. Now let's say we want to okay, I'm going to leave this file untouched. Okay, I'm going to leave this file untouched. So I'll call it one main.c. So let me exit first and rename it 0. Actually, 0 main.c. Alright, so we want to have another copy that will call main.c. That's the one I want to open now and modify, just so that you can see how to do the other one. Okay, let's see. We want to write a program that will check the age of someone and tell us whether or not the person is qualified. I want us to use logical operators. So int age, let's say if age is equal to, you can see the quality sign, right? Is equal to or let's say is greater than or equal to let's say 18, and so put the and put this ampersand twice and say and the same age is less than or equal to 60. So let's print um, you are qualified for the, okay, let's make it like a job, some job interview or something, some job screening. So let's take it down. In Nigeria they can be funny, they will tell you you're looking for 25 or less than. Very funny. Someone that's 25 years of age, okay. And then let's say else, because we want to have more than one condition. Else if, put a bracket, if the age is less than 18, right? Okay, let me just leave it as, okay, if less age is less than 18, it's okay, it's fine. I'm gonna take all of this off, print, you are not underaged. All right, then else, because this is the last condition, there's no point stating it. There's no point stating it. I mean, he already knows. He already knows, because if the age is not between 18, if age is not between 18 and 25, and the age is not less than 18, it will just assume that okay, this is, it will just run this particular condition. Okay, so let's go. Print you are too old for the job. Okay, I need to add a new line of this, right? I don't want our code messed up. So let's go and add new lines up here and add a new line up here. Okay, so I need to close this curly brace for this else statement. Yeah. Alright. So I will just save this. It is saved now. I'm going to run it. Let's make this full and zoom in a bit. Remember, the name is oneman.c. So let's just see oneman.c. I think I want to have the name as one main. Yeah. Just for this to be arranged. One main. Alright, I guess that sentence was wrong. So let me rather do it this way. Alright, so let's do it again. Come on, what's happening? Oh, okay. It's not from that. Okay, I see my fault now. Age, thank you. Age. Alright, so if age is greater than or equal to 18 and age is this, do this, okay? Alright, let's go back. And compile. So now let's run one main. It says you are underaged, please. Okay, let's make it even clearer. Now, why is it putting your underage is please when there is no value here. Let's start to find out what is there. You are percentage I and qualify for the job. You are percentage I and underage, please. Of course, for putting percentage I there, I have to put the variable where to get it from. And then you are percentage I and too old for the job. And then let's come here as well and add this second argument. We're making progress. Now let's compile again. Let's run it again. Says you are 0 and underage, please. Why is it 0? I thought I gave it no value. Why is it 0? Yeah, so why is it 0 now? Where is the 0 coming from? Okay, that's by the way. So let's give you the value of age 23. Age 23. Here we go. If I run it now, it says you are 23 and qualified for the job. If I go back and change the age to 42 and save it and compile this file again and run it again, it says you are 42 and too old for the job. If I go back again and change this age to 17 and save it, come here, compile again, run it again, it says you are 17 and underage, please. These are if else working, but here we have relational operators and logical operators being used at the same time, right? Being used at the same time. Now let's assume that we wanted what life scenario will I use now? Wanted to use the or. Okay, I think you can read up that, right? If we had or here, it means that if any of this is true, the code here will run. If any of this is true, the code here will run. Okay, how do I illustrate that? Using or. What real life scenario I use? Let's try to have another file. I'm going to call it 2main.c. And over here, I'm going to copy what we have in 1main.c into 2main.c. It's not saved yet. 2main.c. Here I'm going to open it. Alright, I'm going to modify it. Let's say we are looking for want to employ some software engineers, and we say that they must be front end or back end developers. We don't want DevOps. So let's say role, right? And here it is. So want to state that if the role is front end or if the role is back end, so you say congratulations, you got the job. I don't want anything here. Then if let me just put an else, okay? So I'm going to cut this off. So what's that? A meta K. Oh no. Else. This. Say print 30%. Sorry. A percentage S is not needed. What is percentage S? Percentage S is the format specifier used for printing string. What is a string? I explained it in the other section. It was recorded. It's on the same playlist. So I'm going to pass an argument whatever is in row, and here we go. So I'm going to close this curly braces, close this block of code for the else. And if else is not a type of loop, mind you, it's a they are conditional statements, right? So let me now say equal to first person that came to apply was a dev up. Let's say dev up, and let's see what happens. Oh, come on. So we're going to compile that code. I'm going to clear this screen, by the way. Let's compile 2main.c and produce an executable called 2main. Of course, the option I think must be here, and there's no problem. Produced it. So it says congratulations, you got the job. Excuse me. Oh, if roll equals this, or let's make this a mistake again, or roll equals this. Print congratulations, you got the job. Okay. Okay. That was my fault. Alright, let's go back again. Compile. Run. So sorry, a dev up is not needed. Sorry, a dev up is not needed. You know what I said? I said if this is true or this is true, tell the person congratulations you got the job. But look at this, it was false because row was not equal to front end. It look at this as well, it was false because back end row was not equal to back end. Unlike the first one we used. For the first one where we use ampersand ampersand, it means both conditions has to be true. But here, if one condition is true, one of the condition given is true, it will run this code. Otherwise, it will go around the else block of code. Of course, you can have several ifs. I can have up to 5 ifs here, right? I'm seeing the hand raised. Please hold on. And now let's make this person. Let's try 2 more rows. Let's say this person is a UI UX designer. UI UX designer. Okay, UI UX design. Let's just say UI UX. It's okay, that's enough. And then if I compile and try to run it, sorry, a UI UX is not needed. Now let's do one more. Let's give it front end. Front end, save it. Look at what it says now. Compile and go. It says, sorry, front end is not needed. Excuse me. Excuse me. That's strange. That's strange. Please ask a question while I figure this out.
I think it will help figure it out, but I was trying to understand why dev up there before you change the condition.
Why?
Exactly same.
Okay.
I think it's similar to why this one is also not
Okay.
so
Why that happened was that this row was not here. So I just added it and then it stopped. So let's find out why this one is not printing. Let's find out. Let me make this service on and this service on. Let's try again. Quite funny. Let's be sure. Alright, so to Excuse me. This is not what I expect. No, 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 no. This bracket in one place. Looks strange, man. Looks strange. I can't figure out why this stuff is not. Yeah, there has to be something I'm not doing right here. If what could be wrong? Okay, so I'm going to stop here for now. Because of time, I'll figure this out and we'll continue from here in the next meet. Does anyone have any question before I leave? I'm serious. So it's working already. It's working. Did you see that? I have to treat it like a pointer. So if I say back end, and compile, okay, let's say relations, you got the job as a percentage S. Okay, you got the percentage S job. So let's be sure which one is printing. So row. Okay, let's compile again. Clear the screen. Rate again. So congratulations, you got the back end job. So you see it's working now. Any questions before I leave? Continue from here the first time. Yeah, next time rather. Congratulations, you got the front end job. It's working. Any questions? I guess there's no questions. I'm going to push this to Git just in case you're interested in playing with the codes and do some more things with them. You're very welcome. You're welcome. Thank you very much for being part of this section. Okay. See you in the next one. Oh, what happened? I'll let you know. I'll inform you. Right? Yeah, inform you. Thank you so much. Thank you. Bye.